Hi everyone. In this final video, I am going to talk to you about the concept of utility. We will see how we can use the amount of utility that someone assigns to an outcome in expected value calculations. That is the expected utility. But also we're going to see how we can use uh, the expected value calculations to determine the amount of utility that someone assigns to some option. And then finally, we'll connect that to understand how the utility of money is diminishing. That is, the more money you have, the less utility uh, money has for you. So let's get started. And I will begin by motivating why we should care about utility. In many cases, when we're deciding between various actions we could take for a given decision, we do not have for the outcomes a precise amount of money associated with them. So in the simple examples which we introduced on Monday and which we have been working through uh, in the reading questions for Monday, and also we will see that on the problem set, there are simple examples of gambles, say, where the outcomes do have specific amounts of value attached to them, i.e. the amount of money won or lost, or in cases where we're considering a company and perhaps making an investment or something like that. In those cases, there is a precise amount of money associated with the outcomes for different actions. However, not all actions in our lives uh, involve outcomes that have particular amounts of money, which we gain or lose from those outcomes. But nonetheless, we want to apply this formula, the expected value formula, to those actions. But the issue then is how do we apply this formula to weight the value of different outcomes of an action if we don't have a precise number associated with the value of each outcome. Um, which not when it's provided by money, that's simple, but in many cases, as I'm stressing, it's not provided by money. And the notion of utility is precisely what fills in that gap. So we can talk about the utility of various outcomes as a number. And this can, first and foremost, help us apply our expected value formula to cases in which we don't have money, but which rather we have to talk more generally about utility. But then, furthermore, for reasons that we'll see a bit of at the end of this lecture, even in cases in which there is a precise amount of money associated as won or lost with an outcome, even in those cases, we do have to not just consider the money, um, but consider the utility of that amount of money, of winning that amount of money or losing that amount of money. Okay. Now there will be many calculations as problems where we simply just calculate the expected monetary value, where we do assume that basically the utility is the same as the amount of money won or lost, but we cannot make that assumption in general, and I'm going to talk about why not at the end of this lecture. But the basic idea for why um, the amount of utility of getting a certain money isn't a certain amount of money isn't just equal to that amount of money, is that the utility of money is diminishing. That is, in general, the more money you have, the less value an extra dollar has. So the difference between having no money and a dollar is a much bigger difference in value than the difference between having, say, $100 versus $101. And we're going to make this idea a bit more precise at the end of this lecture. And then furthermore, instead of saying directly what utility is, we're going to develop a way of objectively measuring the amount of utility an individual assigns to some outcomes. So, but here's one important thing to note about the notion of utility. The notion of utility is subjective. That is, different people value different things to different degrees. So different people might place different amounts of utility on one and the same outcomes, depending on how much they subjectively value it. So for instance, some people value friendship most, whereas others value family more. Some people prioritize professional success, others prioritize activism. So here are cases in which when we're considering what someone should do and the utility of various outcomes, what we have to do is we have to think about what that individual values, what their utilities are, which they assign to those outcomes. And in many cases, those can vary between individuals. Another example is in terms of our musical taste. So some people prefer 80s music, other people prefer rap, other people like nu metal. So in general, the utility a certain outcome has is subjective. And what that means is that the utility varies from person to person. The utility of a certain outcome really depends on an individual's subjective preferences. But despite the fact that there's a certain amount of subjectivity or individual variance to utility, we can nonetheless measure it objectively for a given person. So in this lecture, I'm going to talk about how to do that. But before I talk about how to do that, I'm going to show you how we can do simple expected utility calculations. And this way of doing expected utility calculations is just a very simple extension of the way of doing expected monetary value calculations, which we introduced in the previous lecture on Monday. So when we have an Act A with possible consequences C1 to Cn, then we say the expected utility of A is equal to the sum of the products of each consequence's probability times that consequence's utility. So this is very similar to the general definition of expected monetary value that I gave in the last lecture, and that general definition applied again to where we had possibly many consequences as opposed to just two. And if you recall, in that the definition of expected monetary value with n possible consequences, I used a fancy summation thing. But here I've just broken that down in a maybe less intimidating way. And the point here is just that we sum together, the point here is that we take each of these possible consequences and we multiply that consequence's utility by its probability, and we add all those products up. So again, calculating expected utilities is exactly like calculating expected monetary values, except instead of weighting the amount of money won or lost for each outcome by its probability, instead we consider the utility of each outcome. So when the outcomes are amounts of money, we replace it with the utility of that amount of money. Okay, but in cases where the consequences are not associated with certain amounts of money, we can still talk about the utility of that consequence. So we can think about not just money gained, but we can also think about time lost, friends helped, loves won and lost, and so on. Really, anything we can assign plausibly a number to represent its value or utility for an individual. And then if we have each consequence associated with the utility, we can weight those various utilities by the probability of each of those outcomes happening, and then sum it all up to get our overall expected utility. So now I'm going to move on to talk about how we can use this expected utility calculation to determine objectively what an individual's subjective preferences or their subjective utilities are. So for this first example of how to apply this method, I want you to suppose that you have three options for lunch. You can have pizza, curry, or noodles. Now, suppose further that you prefer them in this order. you prefer pizza the most, and you prefer noodles the least, and in between is curry. So for you, pizza would be the very best option to have for lunch, and then next best is curry, and then the least good option is or are noodles. So now we ask, how does curry compare with the best option, pizza, and the worst option, noodles? Is it almost as good as pizza? Is it almost as bad as noodles? Or is it exactly halfway between? So what we want to do is we want to assign precise utilities to each of these options to see not just comparatively that you prefer pizza the most and noodles the worst and curry in between, but we also want to see with numbers how close curry is to pizza versus noodles. How much more than noodles do you prefer curry? And we can do this with the following method. So to find out, I offer you a choice. The first option you can take in this choice is that you can just have curry for sure. So for this first option, option 1 or O1 here, if you choose this option, you get curry for sure, the middle, the one that you prefer in the middle. Okay, so you can choose to have curry for sure. Or instead of taking that option of having the middle option guaranteed, you can take a gamble. And on this gamble, there's a certain probability P that you get pizza, and then a probability 1 minus P that you're going to get stuck with noodles. Okay, so on this gamble, you either end up getting the best thing or the worst thing. And there will be a certain probability that you get the worst thing, and then 1 minus that probability that you get noodles. Now what I ask is, how high does P have to be? How high does the probability that you get the best option, pizza, have to be in this gamble before you are indifferent between either having curry for sure or taking the gamble? That is, for this gamble here between the best and the worst option, how high does the probability of getting the best option have to be before you'd be willing to put aside getting curry for sure in order to take this gamble? So suppose that you answer that for you, probability P is 2/3. So if there's a probability 2/3 that you get pizza, the best one, then you'd be willing to take the gamble versus getting the middle one for sure. So you'd be willing to take a gamble to get for a 2/3 chance of getting the best option versus a 1/3 chance of getting the worst. And that gamble is equally valuable to you, or you'd be willing to take that gamble instead of getting the middle thing for sure. So for you, let's say 2/3 is the value of P, which make these two options equally good. So now we can apply the expected utility calculation. Okay, so again, what we're assuming is that you're indifferent between curry for sure and a 2/3 chance of pizza versus a 1/3 chance of noodles. Okay, so we're going to make a couple assumptions and do some calculations. So we're going to assume, simply since noodles is a worse option, we're just going to set its utility at 0. And second, since pizza is the best option, we're going to set its utility at 1. Okay, so what we're interested in is simply the relative goodness of curry to pizza versus noodles. Okay, and since we're interested in assigning a number which tells you how much closer to the best option curry is to the worst option noodles, we can simply stipulate what the best and the worst option will have as their utility. And we'll do a simple stipulation where we'll say the worst possible outcome has utility 0, and the best possible outcome has utility 1. And now we can calculate some expected values, or more precisely expected utility. So what we're assuming is that the expected value of getting the first option, which is curry for sure, is the same as the expected value of a gamble, where you have 2/3 chance of pizza and 1/3 chance of noodles, okay? Because we're assuming that you're indifferent between those two options. So that means that their expected utility is the same. So now we unpack this a bit more. The first option, you have a certain probability of getting curry. In this case, you have a 100% probability of getting curry because it's guaranteed. And in the second option, you have a certain probability of getting pizza and a certain probability of getting noodles. And we know what those probabilities are. We know it's 2/3 here and 1/3 here. So we simply fill out the numbers which we know. So we know for the first option, you have a 100% chance of getting curry. So this will just simplify to would be 100%, which will just go away because it's just 1. And then we know the probabilities of these two outcomes for the gamble. And furthermore, we've stipulated that the best outcome will have utility 1 and the worst outcome will have utility 0. So we simply just do some math. And what we see is that if you're indifferent between curry for sure and gamble, where there's a 2/3 chance of getting pizza and a 1/3 chance of getting noodles, then for you, the utility of curry is 2/3. That is, it's a bit closer to 1 than 0. So in general, if we know that someone's best option is B and their worst option is W, we can make the following stipulations: that the utility of the best option is 1 and the utility of the worst one is 0. Okay, so this is just a more general kind of stipulation than in this particular case we just worked through. And then if we want to know how much utility some third option C has for them, we just again do the following. We ask for the lowest probability P at which they would be indifferent between having C for sure versus accepting a gamble where they have a chance P of getting the best option and a chance 1 minus P of getting the worst option. And once we determine what that value is for them, we can simply apply the calculation like we did above. And what we'll see is that we then know that the utility of C is equal to P, the probability of getting the best option in this bet that they are okay with. So again, in general, the reason we know that the utility of this third option C is P is as follows. And this is just really redoing the calculation in the example here, but at a general level, so that we can see how to apply it in other cases. So since the person is indifferent between getting C for sure and this gamble, where this probability P of the best option and probability 1 minus P of the worst option, we know that ultimately the utility of C is equal to P times 1 plus 1 minus P times 0, which just is to say that the utility of C is P. Okay, so here we've shown in general how we can find the utility of some middle option for an individual. And finally, note that, as already stressed, the choice of 0 and 1 as the utilities for the best and worst outcomes were arbitrary. It's kind of like how we can choose different scales for understanding temperature, say Celsius or Fahrenheit. Now these differ in terms of whether the freezing point is 0 or 32. And in the case of utilities, the reason why it's arbitrary that we assign 0 and 1 for the best and worst is that all that matters is the relative amount of utility that an individual assigns to various outcomes. So the absolute number itself doesn't matter. What matters is the relative distance of that number to the other relevant outcomes. And what this method can tell us is how close some middle outcome is to B versus to W. So to go back to the particular example we worked through with what we're going to have for lunch, what we showed was that for this individual, the utility of curry is 2/3. And what that means is that this individual likes curry almost as much as they like pizza, because 2/3 is close to 1. Um, and it's not the case that, for instance, the individual hates curry almost as much as they hate noodles. That would be the case, for instance, if we got that the value here was, say, 1/3, or perhaps lower. So what this method tells us is the relative amount of preference which an individual has. If we already know, for instance, the best and worst outcomes, we can see the relative intermediate utilities that the individual assigns to various other outcomes. So in concluding this lecture, I'm going to now apply this method of determining intermediate utilities to the case of money. And what we'll show is that money has, or what we'll show is that the utility of money is different than its amount. That as we have more and more money, its utility decreases. So let's apply Ramsey's technique, this method that we just went over, to figure out the value of $50 compared with 0 and 100. So let's set the endpoints of the scale as usual. So since 0 is the worst outcome, we'll set the utility of it as 0. And since $100 is the best outcome, we'll set its utility at 1. Now we're going to ask, how high would the probability P have to be before you would trade a guaranteed $50 for the following gamble, where you have a chance P of winning $100 versus a chance 1 minus P of winning 0. So you can take a moment to reflect on what your subjective answer is to this question. But again, the question is, suppose you're offered a choice. You can take $50 for sure, or instead of having a guaranteed 50, you can take a gamble. And this gamble will give you a certain chance of winning $100, but then there's also the chance of winning 0. So how high for you would P have to be before you'd start being willing to take this gamble versus a guaranteed 50? So for me, I'd only be willing to play or take this gamble if P was at least 75. So if the chance of winning $100 was 75%, I would start being willing to take this gamble as opposed to having a guaranteed $50. So that's my answer. Therefore, following the method we just discussed, for me, the utility of $50 is 0.75 or 3/4. And the way we can show that is that since I'd be willing, since I'm indifferent between a guaranteed $50 and a bet where we have 3/4 chance or 75% chance of winning 100 versus a 1/4 chance of winning 0, and then since our stipulations about 0 and 100 being the best and worst outcomes, we simply just show that the utility of $50 is 0.75. So now I want you to note the following. $100 isn't simply twice as valuable as $50. That is, we're assuming that the utility of $100 is 1. And we've just shown that the utility of $50, for me at least, is 0.75 or 3/4. And what that means is that the utility of $50 is actually much closer to the utility of $100 than it is to the utility of $0. So the move from 0 to 50 gives much more utility than the move from 50 to 100. So what does this mean? Well, what this means is that the more money you have, the less value additional money offers. So intuitively, if you have $1,000, another $1 won't make you that much better off. But if you have nothing, a $1 can be very important and very valuable. So what this shows is that ultimately, when we're calculating whether we should make various decisions, even if we do have precise monetary wins or losses associated with the different outcomes. We can't just calculate the expected monetary value. We have to consider the utility of those monetary outcomes. However, just to be clear though, there will still be many questions that we'll work through in this class where we'll simply be calculating expected monetary value for simplicity. But the point here is just that in order to apply expected value theory or just mathematical decision theory to everyday life, we do have to notice that the value of money is not a simple thing where, for instance, we have for each dollar one util or piece of utility. Rather, we have to recognize that the more money we consider, the less or the smaller jumps in utility there will be.